Hi everyone, welcome back. In this third and final part for this week's lesson, we're going to take the kind of dancing line example we just did and just kind of talk about coming up with maybe a slightly more advanced representation of that framework. And as we do that, we're also going to add a couple of, talk about a couple of cool tricks we can do with the GUI, some interesting features in there. So let's jump right in. So what I've done here is, as a starting point, I've taken the example we did in the previous video and simply just made a duplicate of it and renamed it so that we are going to use the same program as a foundation. Okay? And just as a reminder, this is our kind of dancing line program, and what we have here is 2 points that we are animating using Perlin Noise. We are saving these points inside a frame object, archiving those inside an array called recorder, and then this is where we actually do the interpretation or the drawing. Okay? Now, because we're going to be coming up with an alternate rendering, one thing we could do here, we could move this code that's doing the drawing into its own function. Okay? And that allows us to experiment with this framework without necessarily having to get rid of old attempts that we've done. Okay, so here's what I mean. We could say, this could be here, we can call it draw lines, okay? And we're going to move this code into draw lines. So this is kind of one option for rendering this framework, this system, is we can draw lines, but we could also imagine some other interpretations. And then all we're going to have to do is kind of use one over the other. Okay? So this next one we're going to try to do is going to be a little bit more complex. So we're going to use math. So don't be scared. And what we're going to do is we're going to take the 2 points that we're animating and we're going to use them to draw a square. And we're going to use both the position of the points to locate our square, but also the distance between them to set the size of the square, and then the angle between them to set the rotation of the square. So we're going to get some very interesting motion happening with just these 2 points. So let's call it another function here. Let's call it draw squares. And that's going to give us kind of a new space where we can start creating some drawing code, and we can always go back to this version if we're interested in that. Okay, so I'm going to call draw squares here. Okay, so we still have the original drawing interpretation in there, but now we're going to start working in this function. And yeah, so now we can sort of organize things a little bit and keep things separate. So in draw square, what we're going to do is we are also going to iterate over every single frame that we've recorded. Okay? But instead of drawing lines, we are going to draw squares. I'm going to draw boxes. So first thing we'll do is we'll change our rectangle mode to center. Okay? And then inside this, we're going to rely on translate and rotate. So let's put a push and a pop so that as we translate to the location of each square we want to draw, we don't affect the other ones that are going to get drawn. So the first thing we're going to do is we're going to figure out the midpoint of this line. Okay, so what's the point that's halfway between x1, y1 and x2, y2, and we're going to use that as the center of our squares. So finding the midpoint of a line is actually pretty straightforward. We can do a little bit of math, but we can also rely on the lerp function. The lerp function is an interpolation function. So what it does is you give it 2 numbers and then it will figure out the blend between them based on a certain ratio. So if we want to create the midpoint between 2 points, it's another way of saying that is we want to linearly interpolate between x1 and x2, and the midpoint is going to be at 0.5. It's going to be right down the middle, and we can do the same with y. Let's take y1 and y2 and find the number that's right in the middle of these 2 numbers, and that's what we can do with lerp. Stands for linear interpolation. Okay? So it interpolates between 2 numbers and it's linear, which means there's no curve to it. It's just, if you say the middle, you're going to get the middle. Yeah. So let's see if that works. We're going to use these values to draw a rectangle. We're going to say, well, first we're going to translate to this location, and then we'll draw a rectangle at 0, 0. And for now, we'll just give it a fixed size, okay, just so we see that it works. Okay, and made a mistake here. Oh, I've written x1 and y1, x2, y2, and I'm going a little too fast here. So these variables exist over here, right? But what I'm interested in here is the frame object that I'm iterating, right? So I'm iterating over the recorder, looking at each frame individually, which means this is what I want to refer to. So my bad. These variables are actually inside the frame object. This is the thing that we're adding to this array right over here. So when I'm iterating through the array, I need to say frame dot x1 y1 because this is how we've defined it over here. Let's try that again. Okay, so now we get a square that's moving, kind of following the midpoint of the line we had before. Let's also turn off the fill while we're at it because that is going to look kind of better. Okay, cool. And everything else is the same. We can still expand the length of that trail by increasing this number, or we can make it very short if we want to, and so forth. All right, so that gives us the location of our square. Now, the other parameter we're going to control in this square is going to be its size. So for the size, we're going to say take the distance between the 2 points and make that the size of the circle. Okay? So we're going to call this the length of the circle, I guess. We can use len. And to get the distance between 2 points, very easy. We can use the dist function. And we're going to say distance between frame, I'm going to copy paste here because I'm lazy, frame.x1 and frame.y1. Okay? And then the other point is frame.x2 and frame.y2. So we'll take the distance between these 2 points, and that's going to become the length or the size of our rectangle. And we're going to reuse that instead of the number 50. So now not only our rectangle is being moved around, it's animated using the Perlin motion, but because we have 2 points in our framework, we can use the distance between them to change the size of the circle. So very cool. And we can play around with the speed here, right? Again, all these parameters are still there for us to play with and kind of explore the space of possibilities that our drawing machine is capable of creating. All right, so now that we've created squares that move and scale according to those 2 points we have in our framework, the last thing we're going to do, and the most kind of tricky and advanced thing, is going to be calculating the angle of this line, okay? And then using that angle to set the rotation of our square. So that it's more interesting and it's going to kind of spin around instead of just moving like this. So how do we calculate? Let's put some comments here first. So find the midpoint. Okay, so we remember what the hell we're doing. Find the distance between the points. And then the last thing we're going to do is calculate the angle between 2 points. Okay? And by the way, there's a reason we're doing these little 3 ideas here. These are just 3 very common things you might want to do if you're creating some sort of generative system that involves drawing and coordinates. Being able to do these simple calculations is very, very useful. So how do you find the angle between 2 points? We're going to use a mathematical function called a_tan_2. So this is part of P5JS. Yeah, a_tan_2, we can see from the description here, it's going to calculate the angle in radians, very important, not in degrees, from a specified point, right, to the coordinate origin. So what that means is the origin is always 0, 0. Okay, so we're going to have to say, if we want to know the angle, right, we're going to have to do a little bit of subtractions. Okay, so we're going to subtract the first point from the second point, and we treat the coordinates separately. The only tricky thing with a_tan_2 is that just to be consistent with the way that function is normally used in geometry, the first parameter is the y value. Okay, so this is very unusual. It just makes it consistent with the way it's usually being used in math. Just remember that the first parameter is y and the second parameter is x, just to like confuse you a little bit. So if we know 2 points, I'll show you kind of the formula to calculate the angle of the line that's formed between them. It's very simple. We're going to say a_tan_2, and we're going to take frame.y1. We're going to subtract frame.y2, and that's going to give us essentially the vector that goes from that represents this line, okay? And we'll talk about vectors next week in more detail. But for now, just remember that if you have 2 points, you can subtract one from the other for arctan 2. And we'll do the same with the x coordinates. We'll say x1 minus x2. Okay? And we start with the y and then the x, kind of counterintuitively. That's just the way this function has been written. And that will give us an angle in radians that we can use to rotate with. So after we've translated the origin where we want it, we're going to rotate the canvas using this angle. Now that's going to look like this. So if you kind of picture the line that we used to have, we can actually still see it. We can just bring in our draw lines here just to see it. We have the line, right? That this is what we started with, and now we're using that line to sort of frame a box. The center of the box is the midpoint of the line. The size of the line, the distance between the points, is the size of our box, and the angle is the angle of our box. Okay, we can turn off draw lines. We can have multiple things layered, interpreting. And this is just kind of another variation on this drawing machine concept, very simple drawing machine that takes 2 points, animates them using one-dimensional Perlin noise. And yeah, so you could come up with an infinity of variations on that idea. You could add more points, if you wanted to have 3 points moving and figure out a way to connect them in an interesting way. And the nice thing about this framework is that we get this compelling, unpredictable but organic motion from the Perlin noise algorithm. And if we give ourselves a few parameters to play with, we can really experiment on like types of outcomes. So maybe I'm going to make the alpha a lot lower, increase the trail, and really like reduce the speed. I don't know, just to see what happens. And now there's like a lot more like overlap of lines. I get just a very different looking image than what I had before, but still within the same kind of set of parameters. So for your exercise this week, you'll experiment with that, kind of taking this basic framework we talked about and then just coming up with your own visual interpretation on top. I have draw lines, draw squares. You're going to come up with your own version. It doesn't have to be as fancy as this one, but there's so many different ways you could interpret how to draw 2 points moving in space. Okay. Before we wrap up for this week, I also want to talk a little bit about some other cool things we can do with dat.GUI. The first one is you'll notice every time we start this sketch, the controls are open by default. We can close them if they're visually annoying. Sometimes you don't want to see them, you don't want them in the way. We can close it. This could be our default state as well. You could simply say in setup, after you've created the GUI, you could use the close command, GUI.close, and it will start closed. So sometimes that can be nice if you want to create a website and you don't necessarily want to have all the controls open right away. You can default to closed and then just open them if you need to tinker. Okay. So that's a neat trick that we can do with dat.GUI. One more neat thing we can do with dat.GUI is we can create buttons that are going to trigger functions. And here's how that works. For example, let's say we wrote a function called screenshot. And that function would simply take a screen grab of the image our drawing machine has generated. It can simply call save canvas here and create an image called screenshot. Maybe we'll get a JPEG. Okay, so simple little function. And what we'd like to do is create a button inside our GUI to trigger that function. So the way this works is we're going to add a setting. I'm going to call it screenshot. And we saw last week in the video tutorial that we can assign in P5.js to variables, not just values, but we can also assign functions. Okay, so here I'm going to assign my screenshot function. So I'm just using the same names here, but we have a screenshot function down here. So I'm assigning this value, which represents a function, to the screenshot setting. And in my GUI, we are going to add the screenshot setting. And we don't need to put in a range or anything like this because this is simply going to be a button. And dat.GUI is smart enough to understand that screenshot is a function. Therefore, when we run the code and open the controls, we now have this screenshot button that appeared. And if we click it, it's going to trigger our screenshot code. Okay? And if we open it, now we get an image of what was on the screen. So kind of a neat little feature as well. So there's a lot more to explore in dat.GUI. It's actually a very deep library. But as we go along, we're going to add some different tricks as well. So we can create sliders, and we can also easily create buttons by simply making variables that are assigned to functions and then adding those to the GUI. So this allows us to create our own events essentially. So separate from just mouse press, it's actually a button that will trigger this little function over there. All right, that's it for this week. Like I mentioned in the previous video, the creative exercise this week is to take these two moving points framework and build on it, expand on it. You can add points, you can come up with some other visual mapping of your choice. So have fun with it, experiment with it, add some additional parameters if needed, if you want to create some, give yourself some additional options. And yeah, I will see you next week.